Hey everyone, Teacher Chang here, and today we're going to take a look at angle-arc relationships in a circle. Now there are three major types of angle-arc relationships that we're going to look at. And the first one is when we have the vertex of our angle being on the circle. So the vertex is on the circle. Now when that happens, that means the angle measurement is going to be half the intercepted arc. So here we have two examples. The one on the left, we have two chords that forms an angle. And the angle that it forms is angle A. And we can see that the vertex at point A is right here on the circle. Now, if that angle is opening up, we can see that it's opening up so that it intercepts that arc BC. So it opens up right over here, intercepting the arc BC. Now, that means the measurement of angle A is going to be half the measurement of that arc BC. Now, on the right, we also have another type of angle where the vertex, once again, it's going to be right over here. This time it's B. The vertex is still on the circle. And what we can see here is that this angle, angle B, when it's opening up, the intercepted arc is still going to be at BC. So from B to C is that intercepting arc. So that angle B, the angle B is going to be half the measurement of arc BC. So let's go ahead and take a look at some examples here. So here we got three examples. We're going to take a look at them one at a time. We'll start off with the one on the left. So based off of the information here, what we want to do is we want to figure out, okay, well, what is the measurement of X and Y? Well, one thing that we got to keep in mind is that in a circle, there's a total of 360 degrees. And the other thing that we want to keep in mind is that when we have a diameter, that's going to cut something in half. It's going to cut our circle in half. So here we have a diameter, which means the top half of our circle is a total of 180 degrees, and the bottom half of our circle is a total of 180 degrees as well, giving us a total of 364 to circle. So if I take a look, if this measurement right over here is 130 degrees, well, that means the other half is going to end up being, that's right, 50 degrees, because it has to add up to 180. The same thing goes for the other one. If this right here is 70 degrees, so this is the bottom portion. If this right here is 70 degrees, well, that means this side over here has to be 110 because it has to add up to 180 degrees for a half of a circle, a semicircle. So what we want to do is we want to figure out, okay, well, what is the values of X and Y? Now, according to our definition, we stated earlier that the angle measurement, so if I'm looking at angle X, the intercepted arc is this 110. Okay, so that means angle X has to be 1/2 of 110. Well, 1/2 of 110, or 110 divided by 2, that's going to give me 55. So we know that angle X is 55 degrees. We could also do the same thing on the other side. If we want to figure out, okay, well, what is angle Y? Well, if I take a look at angle Y here, well, the intercepted arc is right across at 50 degrees. So the arc itself is 50 degrees. Well, Y is going to be half of 50, and half of 50 is 25. So that's 25 degrees. So we now found X and Y. And the same thing goes with the second one. So the second one, it's a little bit reversed. So here it's a little bit different. And what I want to do is I want to figure out, okay, what are the values of X, Y, and Z? So if I take a look at X, well, right over here is X. Now X is an arc. It's not an angle. But the angle that is being formed from this arc is 61. Now that 61 is half of X. So what we have here is our arc is going to be 2 times that 61. So that X is 2 times 61 because it's twice the amount of that angle measurement. So 2 times 61 means that that angle, or that arc X, is going to be 122 degrees. Now if we know that this is 122, and we can see from the rest of our circle that this is 90 right here, and this is 100. Well, if I go ahead and go all the way around my circle, I can figure out, well, what is Y? Really, what I need to do is I need to take my 90 plus 100 plus 122 plus y, that all adds up to a full circle, which is 360 degrees. And we could do a little bit of math here. We could go ahead and combine our 90, our 100, and 122. And if we add those together, we get 312. So now we got 312 plus y is equal to 360. And well, we subtract 312 on each side. So if we subtract 312 on each side, the 312s on the left will cancel each other out, leaving us with our y value. And our y value in this case is 48 degrees. Okay, so now I know what y is. Now remember, y is going to be twice the length of the angle z. So if we take a look at angle z has to be half of the intercepted arc, and the intercepted arc is 48. So that means we have to go ahead and take that 48 and divide it by 2. Now 48 divided by 2 is going to give us angle z. So that's going to give us 24 degrees. Okay. All right, let's take a look at this next one here. So here we're going to take a look at a triangle inside our circle, and each of these vertices are touching the sides of our, is touching the edge of our circle. So this is called a circumscribed circle. Now, if I take a look at each of these, that x, the opposite angle of that x, is coming from angle that has a measurement of 50. So this angle that has a measurement of 50 is going to intercept that arc x, which means x has to be twice that size, so that means x has to be 100. Okay, remember the arc is twice the size of that angle. All right, now if we take a look at the 60 degree mark, we could see the side that is opposite of that 60 degree, or the arc that's opposite of that 60 degree is going to be arc y. So we can see that right over here. So that means arc y has to be twice 60, and well, 60 times 2 is 120. Okay, and that leaves with angle z. Now there's or arc z, and there's a couple ways that we can do this. One of the easier ways to do this is to just go ahead and remember that a full circle has to add up to 360 degrees, and we already have 100 and then 120 here. So if we add 100 plus 120 plus z, that should add up to 360 degrees. Okay, so now we just go ahead and combine the 100 and the 120. That's 220 plus z is equal to 360. And then we just go ahead and subtract 220 on both sides. And that means z has to be 140 degrees. Okay, so remember, the rule for a point or where the vertex is on the circle, if the vertex is on the circle, it's going to be 1/2 the intercepted arc. All right, let's take a look at the next one. The next one is when the vertex is inside the circle. So if the vertex is inside the circle, well, that means we're going to take half of the sum of the intercepted arcs. So if it's inside the circle, let me fix that really quickly. If it's inside the circle, that means it is half the sum of the intercepted arcs. Now remember, the word sum means addition. So that means we're going to be adding some things here. We're going to be adding the two intercepted arcs. So we're going to add the intercepted arcs. Now there's going to be 2 of them. So for example, if our vertex, in this particular case, the vertex is this point at D, the intercepted arcs, depending on which way you're looking at, in this particular example, they're looking at the arcs over here, EG and FH. And the reason why they're looking at these 2 arcs is because they're looking for angle GDE. Well, GDE is this angle right over here. So the intercepted arcs are going to be arc EG or GE and arc FH or HF. So let's take a look at an example here. So this first one on the left, well, we'll take a look at 3 of these. The first one on the left, it's a very similar situation. Here we have our arc or our angle X, and the intercepted arcs are going to be the 138 and the 42. So remember, if we go all the way across, here it's being formed by two chords. The intercepted arcs are going to be at 138 and 42. So that means to find angle x, that means x is equal to the sum of these two. So that means 138 plus 42 divided by 2, because we want 1/2 the sum of the intercepted arcs. So if we do the math here, 42 plus 138, or 138 plus 42 is 180. Divide that by 2, and well, x is equal to 90 degrees. Obviously, it's not drawn to scale, but from this process, we know that it should be 90 degrees. All right, let's take a look at the second one. The second one is similar, yet slightly different. So if we take a look at this one over here, here's x. That's what we're trying to look for. And the intercepted arcs are going to be the ones that are blank. So there's a couple of ways that we can do this. We can go ahead and solve for this one first. So if I go ahead and solve for that missing arc, well, the same thing, that question mark is going to be the two intercepting arcs, which is 95 plus 117, and we're going to divide that by 2. It's half of the sum of the intercepted arcs. So that's now going to give us 212 divided by 2, which is equal to 106. Okay, so now we know that this is going to be 106 degrees. Now these two arcs, or these two angles, are congruent because they're vertical angles. Now what we want to do is we want to figure out, well, what is x? Well, x is right over here. And remember, right over here we have 180 degrees because it's a straight line. So all we got to do is take 180 minus 106, and that's going to give us x. So x is going to equal to 74 degrees. All right, we got one more, and this one's a little bit different because this time we're missing one of our arcs. So here we're missing one of our arcs, and we do have our angle measurement. So they did give us the angle measurement. So the angle, once again, the angle is equal to, and that the sum of half the sum of the intercepted arcs. Well, the intercepted arcs are x and 134. So that's these two arcs right over here. So the intercepted arcs are right over here. So x and 134. So that means I'm going to do x plus 134 divided by 2. Okay, so now all I got to do is the math. I can multiply both sides by 2. That's going to get rid of that 2 on the bottom, leaving us with 202 is now equal to x plus 134. And now all we got to do is subtract that 134 on both sides. And the 134s will cancel each other out, leaving us with x by itself. And now we can figure out what x is. X ends up being 68 degrees. All right, let's go ahead and take a look at our third major type of arc-angle relationship, or angle-arc relationship. And in this case, we have the vertex being on the outside of the circle. Now, if the vertex is on the outside of the circle, that means it's half the difference of the intercepted arcs. So if it was on the inside, we did the sum, but now we're doing the difference. And remember, difference in math means to subtract. So we're going to subtract two arcs. Now when we subtract, in order to avoid some negatives, we always take the big arc minus the small. So the larger arc minus the smaller arc when we find the difference. All right, so let's take a look at this particular example. Here, this time, we have our vertex on the outside, which is point J, and the angle that is being formed is this angle right over here. Okay. And the arcs that are being intercepted in this particular case, well, the bigger one is this one right over here, MN or NM, and the smaller one is this one over here, KL or LK. So we're going to do the big minus the small, and we'll divide it by 2, or 1/2 the bigger arc minus the smaller arc. Okay. Okay, so that's how we go ahead and find that angle measurement. So let's take a look at this first one on the left, and this is basically what we just stated here. So if I take a look at my angle at this point right over here, angle 1, and it creates this right over here. We have two secants here, and the arcs that are intercepted is going to be this 50 and this 100. So those are the two arcs that's being intercepted here. So when I want to go ahead and solve for angle 1, what I'm going to do is I'm going to do 100, the bigger one, minus 50, the smaller one, and divided by 2 because I want half of it. So that means 100 minus 50 is 50, and 50 divided by 2 is 25 degrees. So angle 1 is 25 degrees. Okay, that's not too bad. Let's take a look at this next one. So here we got angle 2, and this time angle 2 is being created by two tangents. Okay, and the intercepted arcs is pretty much the entire circle. So we have the first one, the larger one, which is 260. And then we have the smaller arc, which is the rest of the circle, and that's going to be 100. So we're just going to subtract those two and divide it by 2. So here, if we take a look at this, we have angle 2 is going to be the larger arc, 260, minus the smaller arc, 100, and we'll divide it by 2. Okay, well, 260 minus 100 is 160, and 160 divided by 2 is going to give us 80 degrees. So angle 2 is 80 degrees. All right, the last one in this particular case, once again, the vertex is on the outside, so this is angle 3, and this is being created by a secant and a tangent. Now, the thing here is that we need to look for one of these arcs here, because I do have the smaller arc right over here at 100 degrees, but what I do need is this other half right over here. This is unknown. Now remember, a full circle is 360 degrees. So we got 100 for that smaller one, and then we have the 60 on this outside. So that's a total of 160, which means 200 is left over. And that's going to give us a full circle. So 100 plus 200 plus 60 is going to give me my 360. So now I know my larger arc. So now all I got to do is to do the math. So if I go ahead and do the math here, I'm just going to go ahead and let's do orange here. If we go ahead and look for angle 3, I take the larger arc, 200, minus the smaller arc, 100, divided by 2. Well, 200 minus 100 is 100, and 100 divided by 2 is 50. So angle 3 is equal to 50 degrees. All right, so those are our three major rules. The first one, again, is when the vertex is on the circle. And if it's on the circle, all you got to do is take half of the intercepted arc. If it's inside the circle, well, that means you got to add the two intercepted arcs and divide it by 2, or take 1/2 of the sum of the intercepted arcs. And if the vertex is on the outside of our circle, then we'll go ahead and find the difference of the two intercepted arcs and divide it by 2, or 1/2 of the difference of the intercepted arcs. Okay, I hope this helped out. If you have any questions, go ahead and feel free to leave a comment. I hope you liked this video. If so, go ahead and give me a like. Don't forget to subscribe. And good luck, enjoy, and have fun.